Okay, quiz. Of course, two numbers would differ from the numbers I have here, but the process is identical. This is 0. Well, it's obvious if x is 7, you're going to have a 0 here, right? And 0 times whatever x plus 12 adds up to, which would be 19 in that case, it doesn't matter. Doesn't matter what this adds up to. If this is 0, the product is going to be 0. And similarly, if x is negative 12, then this part is 0, which means the product has to be 0. So you write this as x minus 7 equals 0 or x plus 12 equals 0. And it's, I think open math tells you that called the zero property of multiplication, which just says if you multiply any set of numbers and one of them 0, you're going to get 0, right? Okay, well, then you easily solve this equation, x equals 7. X equals negative 12. Simple enough. Now, when you come down to this one, again, you use the zero property of multiplication, which tells you that this is 0 if 4x plus 9 equals 0, or x minus 5 equals 0. Well, you solve this, you're going to get equals negative 9/4 or x equals 5. And I'm not going to go over the details of how you solve this one because I didn't leave myself enough room to simply have to know how to solve linear equations. Okay. And I've said if you have trouble solving linear equations, you really need to get to the mark, get online, do something. Okay. So the next question asks you to multiply. Now, of course, these numbers are the same as these, or this expression is the same as this. You're going to multiply it out. By the distributive law, x minus 7 times something is x times that something minus 7 times that something. Okay? So x minus 7 times x plus 12 is x times x plus 7. Minus 7. X plus 12. You understand that well? Okay. Again, make sure you understand the distributive law. So we've got to use it again. Now, what's x times x plus 12? X times x plus x times 2. This times this plus this. You multiply these, and then add. And then you have minus 7 times x and minus 7 times 12. Actually, written that out a little more completely. It's plus okay, so x times x is x squared. X times 2 is 2x. Then we have minus 7x. And that's minus 84. Finally, that's x squared minus 5x minus 84. So that's how we use the distributive law. Now, people will often do this. I don't particularly like it, but actually I do it. I'll do this, but this isn't the distributive law. It's just what results from the distributive law. Okay. Now, if I wanted to graph this, I didn't ask you to graph this, but if I wanted to graph say, well, let's see. This is equal to 0, so if this is y, then I can put this on a graph of y versus x. And y is going to be 0 when x is 7 or when x is negative 12. So I can put negative 12 here. I can put 7 here. Oh, right. Okay. Then I could say, okay, well, if x equals 0, this gives me negative 84, right? I'll get the point. Here. 0, negative 84. Now, if x is a really big positive number, then both of these are really big positive numbers. Like if x is a zillion, or a zillion 7 and a zillion 12, or a zillion minus 7, a zillion plus 12, pretty close to just a zillion times a zillion, right? Whatever a zillion is, very big number, okay? Which means that when x gets big, this thing is going to be positive. If x is a big negative number, like negative a zillion, then effectively we just have negative zillion times negative a zillion. Negative times a negative is big, is positive. And a zillion times a zillion is really big. So this tells us to the left of negative 12, well, the big negative numbers goes up fast. Okay. Also, we can say, if x is bigger than 7, then x minus 7 is positive, right? And x plus 12 is positive. So the thing has to be positive to the right of 7. If x is less than negative 12, well, if it's less than negative 12, then subtract 7 is going to be even less, right? It's going to be negative. And x plus 12 is going to be negative if x is less than negative 12, right? So we know that the thing is positive all the way to the right of x equals 7. It's positive all the way to the left of negative 12. So now we can sketch a graph. It might look something like this. Well, that's really lopsided, but that would be a conceivable graph. Okay. Now, if we want to graph this, well, we know zeros if this quadratic is equal to 0. Okay. Now let's take a minute. This says it's not written very well, but it's written well here. Set that equal to 0 and see what the quadratic formula tells you about it. Okay. We ought to prove it's that. I think that's that. I'm not sure. No, it's not. Still doesn't want to be in focus. There it is. As soon as I reach for the remote, it knows it's got to cooperate. I'm going to do something. Okay. I'm going to keep that picture up there for a minute. So I wrote down 2 here instead of 12. Okay. So just like seeing the 12. should have been. So that was my mistake, but that's okay. What you did was fine, and you'll understand because all the numbers are going to be the same as they were on your paper, except the solutions are going to change sign. And that's just a lucky break because the difference between 12 and 2 is 10, which happens to be twice as big as the number we get here. Okay, well, anyhow, here we have it. Here's our equation, the equation that I intended to ask you. And here we have the solution. All we have to do is plug A, B, and C in. B is the number in front of X, the coefficient of X, that's 5. We have -5 plus or minus the square root of 5 squared minus 4 times A, and A is the coefficient of X squared, that's 1. Everybody knows that. Repeat it. And then we have -84 here. Let's write things down carefully. In the denominator 2A, 2 times 1. I'm not going to write out all the steps to do this. If you're careful, you do have to watch out for the negative of the negative, right? It's really easy to get the sign wrong here. Okay, so square of 361 is 19, so -5 plus 19 gives you 7. -5 plus 19 gives you 14, divide that by 2, you get 7. -5 minus 19 is -24, divide that by 2, you get -12. So the zeros are at the point 7, 0, -12, 0, because when X is 7, this is 0. You can verify that. X squared would be 49 if X is 7. And 5 times 7 would be 35. 49 and 35 adds up to 84. 84 minus 84 is 0. So once in a while you want to do that to remind yourself of what all this means. You put in -12, you're going to get 144 here, and then minus 16 minus 84. 1684 is 144, so you have 144 minus 144, you get 0. And again, it's always good to do that once in a while. So what we see about the graph is we have zeros at -12 and 7. Now, that should look familiar because that's what we have here, right? Now, why did we get it here? Well, because this is just this times this. There's no difference between the values of this and the values of this. They're exactly the same. At least they give you exactly the same values for any given number X. So the graph should be identical. Now, we didn't know that when we did this because we just graphed it based on the zeros. My graph is all lopsided. We can observe this is a quadratic function. So we have an axis of symmetry. Okay. We've done that in here, haven't we? Axis of symmetry and all that. That's what we've been doing. Got to do it in another class as well. So I want to make sure I'm not getting confused about what I'm doing with it. Pretty sure. Okay, so here we have it. And now, what's the other thing we can do? The y-intercept. Average can X equals 0, so y would be 0 squared. Plus 5 times 0 minus 84. It gives us the point. Zero minus 84. So it looks a whole lot like what we had here, doesn't it? Look at 7. Maybe a little short, so I'm going to put 7 over here. A little bit. That'd be a better place for 7. So that's my y-intercept. Here are my zeros. And I know the graph goes up over here, it goes up over here, so it has to do this. I also know now that I multiply this out, that this is a quadratic function, right? So if I'm used to distributable, I can look at that and say, well, that's going to be a quadratic function. So the axis of symmetry is going to be halfway between the zeros, and I don't have to do that. However, we want to relate this to what we already know. So the axis of symmetry is a line x equals negative b over 2a, which is negative 5 over 2 times 1, which is negative 5 halves. So negative 5 halves is negative 2.5, right? Let's do that accurately if I want to. I can divide this interval in half, that'll give me 6. Divide this one in half, that'll give me negative 3. So negative 2.5 will be about here. Right there's the line x equals negative 5 halves. It's our axis of symmetry. If the thing was in this form, I'd say, well, halfway between negative 7 and 12, add negative 7 and 12, you get 5. And of course, the average two numbers, you add them and divide by 2. So you're going to get 5 divided by 2, which is negative 5 divided by 2. Well, zeros are negative 12 and 7. Negative 12 and 7 is negative 5. And you divide that by 2, you have negative 5 halves. Okay, so here's your axis of symmetry, and you got to go through these 3 points. How hard is it to do that? Well, if you want to make it look really, really good, it's kind of hard. But if you're willing to be a little sloppy, but not as sloppy as I was here. Of course, here I was pretending I didn't know this is so cool. So here we come on down. One down here, double off at this point. Come back up. I think that's a pretty good parabola. Must have been an accident, so I never did parabolas that well. Okay. So right there's our graph. Simple enough. Well, this tells us a couple of things. One is, if we have it in factored form, we don't have to go to quadratic formula. So this is factored form. Okay. So this is general form. And this is factored form. Factored form is much easier to deal with. Well, now let's consider this third question I asked you. What's the graph of, well, I don't think I've written a polynomial down for that. Or have I don't even know where my, the board. Okay, never mind. That's okay, so. Okay, well now, board a little bit, show what I'm showing. Okay, again, here's the factored form of the polynomial we've been dealing with. Here's the general. What a graph. I'll write it a little bigger so you can read it. Y equals, it's plus, plus, minus, it's D. Let's say, and X plus D, which I'll say is 6, times X minus A, was it? X minus C. That will make that 8. And how do we graph it? Well, it's really easy to find the zeros, right? You set this equal to 0, set this equal to 0, set this equal to 0. Okay, so the zeros get -10, -6, and +8. So we sketch the graph, such as it is. Okay, and we say, okay, well, if let's say -8 is here, and 8 is out here underneath the distance on the x-axis. So let's say that -4 would be here, -2 and -6. Math tells us -10 will be this part of the left. So there's -10. And of course, here is -6. So I've got a 0 here, a 0 here, and a 0 over here. So my graph has to go through those 3 points. Then the y-intercept will be y equals 10 times 6 times -8. Because, of course, we put in x equals 0, that's what we're left with, right? Then we multiply that out, we get -480. So we better hope that we don't have to use the same vertical scale that we do the horizontal scale, because -480 would be several feet underground. So we don't have to scale the graph equally, though. So we're going to put -480 here. And it's 0, -480. -480 is 0. I don't have to write that 480. Right? Okay, now, if x is -0, in other words, really big negative number. So if the 10, the 6, and the 8 don't make a hill of beans of difference. Okay, then we get a negative times a negative times a negative, right? Not only is it then negative, but we're multiplying 3 really big numbers, we get a really big negative number. Huge, humongous. Okay? So I know that the graph pretty rapidly goes down over here. And over here, same type of reasoning. If x is plus a zillion, plus a big number, you're going to get a positive times a positive times a positive. It's going to be positive. Okay, well, that means that the graph is going to come up here from lower regions. Going to turn around, going to come way down probably. Yeah, probably. Not, probably not. And I can't decide. I don't like the last part of it. Okay. Let me try again. Okay, actually, I think it's going to come down kind of like this. And go to the lowest point. Well, this isn't going to be the lowest point here. Very unlikely that your y-intercept is going to be your lowest or highest point. So don't try to make it the lowest or highest point. You try to do the curve that makes the most sense for these 3 points. As it turns out, it looks like it's going to be pretty close to that low point because that's kind of the way the curve dictates. It's not the best curve I could have drawn. If I started over, I might be able to do better, but it might even be worse. Okay, so right there we have the approximate graph. Y equals okay. Okay, well. Now, I want you to see what this polynomial looks like if it isn't factored. Okay? So, we do this expand. This. Okay? Now, if multiply x plus 6 by x minus 8, you get this, right? Y is x plus 10 times x squared minus 2x minus 48. So I've already done half of it for you, right? But you still got to expand this. Now let me say one other word. There's an F word, worst word in the human language. Starts with F, it ends with L. You know, it's what people want to do when they see something like what we have over here. Okay? You know what word I'm talking about? You've probably seen it, probably used it a lot. And Open Math is going to use it. Yeah. Like, you got to tell me what the word is? Okay, instead of telling me what the word is, can you show me with your fingers what that letter should be? Okay, that should be an O. Okay, somebody else tell me what letter might go here? Indicate with your fingers, yeah. I, right? I just like it, but we are going to use it for factoring in a few minutes. Factoring trinomials is the one place where that terrible word can be very helpful, okay? And it's associated with what you do with these things, okay? But it's the distributive law that you're using, and this obscene word will not help you multiply this, right? You got to use a distributive law. So go ahead and see what you can do with it. Okay, let's be sure everybody's got this now. What's x plus 10? Let me ask you this before I go on. Just want to be sure everybody understands this, okay? Start out with x plus 10 times 14 would be. Can everybody do this, whether you got it or not? Give you a minute, see. You can write out what x plus 10 times 14 would be. x plus 10 times 14 means x times 14 plus 10 times 14. Okay? With numbers, let's say we have seven plus 10 times 14. Okay? That equals 7 times 14 plus 10 times 14, which equals 98 plus 140. Okay, so that's what we get if x was equal to 7, right? If I multiply some two numbers by another number, I can multiply the first number by that number, and I can multiply the second number by that number, and add them up. And to see that that works, 7 plus 10 times 14 is 70 times 14, which equals 980. Cool. 17. 7 plus 10 is 17. Now, 7 times 10 is 70. I know that. Anyhow, 17 times 14 is 198 plus 42, which is, whoa. 198 plus 3 times 196 plus 32. So that's 238. 98 plus 140 is 238. Now what this demonstrates is that if I have a sum multiplied by a number, okay, I could do the first number times that number plus the second number times that number. I get the same thing as if I add these up and then multiply it. Okay. And it demonstrates the truth of this expansion. If x happens to be 7, then this is what I get. Okay, I get 98 here, 7 times 14, 10 times 14, same things I have down here. And either way, I get 238. Now, again, if you're having trouble with the discrete law and the general of algebra, and you know, not everybody's here today, but there are people who really need to get to the mark and get the discrete law. Learn how to solve linear equations. Okay? We're talking about people that do fine with quadratic equations, right? It's not a lack of ability to do it, it's a lack of having seen enough of them, okay? So we got to get that. We got to get that. So anyhow, x plus 10 times x. Okay. That's x. And x squared minus 2x minus 48. That's 10. And x squared minus 2x minus 48. And then that equals, of course, we distribute the x through here, we distribute the 10 through here. So x times x squared. So plus x is times negative 2x. Plus x times negative 48 plus 10 times x squared plus 10 times negative 2x plus 10 times negative 48 times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 48 is negative 48x. 10x squared is just 10x squared. 10 times negative 2x is negative 20x. 10 times negative 48 is negative 480. Now, I've got a couple of x squared, so I've got a negative 2x squared and a 10x squared. So what we have then is x cubed. Because there are no other x cubed in here. And that is negative 2x squared plus 10x squared is -8 x squared. Then we have a couple of x terms, -48x and -28x, which is then -68x minus your 480. Okay. So the distributive law always works. It doesn't matter if I have a polynomial over here with 8 terms and one over here with 10 terms. I'm going to give you a total of 80 multiplications, and then you got to simplify. It'd be a mess. And nobody in their right mind would actually do that unless there was terrible consequences for not doing it or terrible reward for doing it. Okay. But there we have it. Now, the graph we just made somewhere, where is it? Is the graph of this polynomial. If I'd given you this polynomial and told you to graph it, you'd be justified in reaching for the graphing calculator. There's no good way that you're going to learn in this course that allows you to determine whether zero is this or not. Turns out that if you know a little calculus, you can figure out what this point is and where this point is, the high point here and the low point here. And that's pretty easy. You already know how to do that, except you don't know calculus. That's one of the easiest things you could do in calculus. It's one of the easiest expressions you could have to deal with in calculus. Very straightforward to do what's called take its derivative, which means find the function that gives you the slope of this thing at every point. Set it equal to 0 because the slope is 0 when you're here or here. Well, you don't have to remember that. Trying to get you excited about learning calculus. You excited yet? Okay. It ought to interest you actually, but if it doesn't, that's okay. Just plod through it. Try to develop interest when you can. Okay. This should demonstrate to you that, well, it's easy to graph a polynomial when it's already factored. If it's in general form, it's not so easy. Okay? You don't really have a good method. Okay, we're almost out of time, so I don't have time to begin to show you factoring. But I think, let me just check and make sure your assignment makes sense here. Okay, I've moved the assignment that was due on Thursday to Friday, so I can tell you what you need to know. Also, when I look at that assignment, the name I gave the assignment, factoring monomials and monic trinomials, which is fairly easy, doesn't reflect what's done in the assignment. It's just thrown out to the wolves with all these trinomials. So I've got to change that assignment. So, okay. It's just unrealistic. It was, I don't know how that got in there, although I'm the one that put it there, so I guess I do know how it got there. I don't remember what I was thinking when I did that. So there's going to be an alternative assignment. Also, I will say that some people did at least some work on the thing I said I was going to omit. And so if you did, I'm going to give you some extra credit on it. I didn't omit it because somebody had already started working on it. And then I neglected to email people and say, you're working on it. Okay, but you don't have to. Okay. But it's very good for you if you do. You're going to learn stuff that's important for calculus. We right now don't have time to do that. Okay. So here we have it. So good luck, and I'll see you Thursday.